Hello, this is Steve Scully. Welcome back for Chapter 6 of the Instruction Manual as it is written in the Cosmos. We are on Section C, the Innovation Paradigm Shift Singularity. Across history, innovations have reshaped society. Inventions such as the printing press, engines, electricity, radios, telephones, computers, and the internet have had major impacts on global scales. These, coupled with all forms of innovation, have moved our collective body to where we find ourselves today. This is represented in Figure 34 below as growth over time. With each innovation comes a peak of growth that can occur with it, like a change to environment to one of higher energy density. In the earlier phases, these innovations were rarer and had less impact on the overall shape of society. As time passed, their capacity to reshape the world we live in became so large that the state of society has evolved distinguishably with several innovations, and as the rate by which they came has increased, so time between them grows shorter and shorter. For example, the printing press allowed for rapid dissemination of information and was a huge step forward for society. However, it did not provide means for the structure of society to be so changed that the way people lived their day-to-day lives drastically was modified. Functionally, people lived similar lives before and after the printing press, at least relative to larger changes, such as the invention of the engine and automobile. These began to impact people's lives substantially. Not only could they receive information more easily due to the printing press, but the automobile assisted in providing the capacity for people and cargo of all varieties to be transported rapidly. Next to computers and the internet, though, automobiles still did not transform the day-to-day life of people that substantially. With computers, a whole array of jobs existed that did not prior. People's day-to-day life became far more sedentary and differentiated from lives before than the automobile's effects had. Even before cars, people moved around. The life of the average person was much more similar before and after the car than it was prior to computers and the internet. Of course, these are all hugely impactful innovations in their own rights, and it is the combination of each together that lays the framework for new innovations to occur. However, with each innovation, the growth is more and more. This appears to bring with it an intrinsic problem that the time before decay occurs is growing shorter and shorter. This shortening of paradigm shifts is thought of as the approaching singularity, when the time between paradigm shifts approaches zero. John von Neumann stated, quote, "The ever-accelerating progress of technology gives the appearance of approaching some essential singularity in the history of the race by which human affairs as we know them could not continue." End quote. As society grows, it requires increasing energy density to grow. As things are presently going, society is on a crash course for some inevitable paradigm shift singularity, a point in time when things must change. What happens next? If innovation slows, society slows. The growth of society would peak and then begin to, slowly at first, then rapidly descend. In other words, society appears on an inevitable crash course for collapsing. The question regarding this issue is, how do we avoid this collapse? After all, no one wants to struggle. Everyone wants to be free to do as they please. If society crumbles around us, what will happen to our freedoms? Firstly, this collapse is avoidable. We cannot stop it, however, if we do not understand it, particularly if we do not understand the underlying mechanisms at play in the complex system of society's motions. As has been discussed several times, the same principles of the periodic table can be related to what is happening in society. As innovation occurs, the mass of society physically grows. In its earlier stages, it is low in mass, and so growth does not create any noticeable instability in the society as it functions. With each innovation comes more growth, and so society moves upward through the periodic table, becoming larger and larger, quote, elements. Over time, society comes to enter the realm of radioactive elements. These have extremely low half-lives, some being unable to exist in experimentation for more than a fraction of a second. And yet planets exist, and stars, and beyond. How could this be? When a single atom cannot reach the mass of a planet, what makes a planet so capable? The answer is that the planet is not a single atom, but rather is a system composed of many atoms. With each innovation comes a higher energy density environment, and our society functions like to an atomic mass moving up through the periodic table as a result. Each new innovation causes growth, leading us to approach the paradigm shift singularity, which is where the radioactive state of society manifests. This is even reflected in the present nuclear age. Therefore, the solution is simple. Like the atoms of Earth, we must merge into a single system. Though we function as a society at large, we each lead individual lives with each of our personal alignments and priorities. Like many atoms near enough to one another, we interact, at times joining with one another, and at times pushing apart from one another, dependent on how our fields interact. However, we are not yet close enough for us to all be part of a single cohesive unit. In a way, we are witnessing the birth of a planet, or of a star, where the energy brought with innovation acts as the, quote, stellar nursery. In interstellar space, clouds of atoms have come together into conglomerations, dense regions, which then come together and form stars. We are each like the atoms, forming together into the conglomerations which attract and repel one another. Each are members of the conglomerations of each nation, of each religion, of each belief, of each idea, just as they are individuals themselves. These groups can either attract one another or repel. For example, friendly nations are attractive to one another, while enemy nations repel one another. The same can be said of belief systems. As these conglomerations grow, just like a star being born, regions become sufficiently dense so as to draw in surroundings and conclude in producing a single cohesive unit. When this occurs, where we are a single cohesive unit as a society, then we will escape the paradigm shift singularity because we will evolve to the next level. We become like the hydrogen atom once more of the next octave. Stability returns and a long-term balance in society results. This transformation process requires energy. Energy can come from various sources, but each is limited in its own way. Car engines cannot bring peace, for example. They can only do what they are capable of from an energetic, transformative standpoint. This is because of how activation energy functions. Section D, activation energy. There are countless parallels between how the physical universe functions and how consciousness functions because they operate identically. In chemistry, activation energy is the minimum amount of energy which must be available to a chemical system with potential reactants to result in a chemical reaction. For example, hydrogen and oxygen gas can coexist without reaction, but when energy is input, a flame, then the reaction proceeds. A chemical reaction itself can be either endothermic, where the reaction proceeds with the absorption of heat, or it can be exothermic, where the reaction proceeds with the release of heat. In both cases, the system remains at a given state until sufficient energy is input so as to cause the reaction to proceed. This is the activation energy. In an endothermic reaction, the energy of the original reactants is constant until it is increased to a sufficient degree by an input of energy where the barrier of resistance is overcome and the reaction proceeds, producing a new, higher energy state due to the absorption of heat, as shown in Figure 35. In an exothermic reaction, the energy of the original reactants is constant until it is increased to a sufficient degree where the barrier of resistance is overcome and the reaction proceeds, producing a new, lower energy state due to the release of heat, as shown in Figure 36. So in both cases, there's an input of heat and then the reaction proceeds, and whether or not it drops to a lower state with heat out or it increases to a higher state with heat in depends on if it's endothermic or exothermic. These same principles can be applied to how consciousness functions by observing that we ourselves require a sufficient activation energy in order to undergo a change of state. This reaction proceeds only when sufficient energy is input. For example, if someone chooses to learn a new language and does so for a day or 3, they have begun to input energy into that specific area of their awareness. However, if the activation energy is not input, then the reaction will not proceed, and instead they will fall back to their original state over time, just as a reaction would. When sufficient energy is input, then they will break through the barrier of resistance and enter a new steady state. This requires more energy than the steady state itself, but the overall outcome of learning a language begins to manifest. This does not happen at once, but rather repetitively as new states are reached. This would be an example of an endothermic reaction. Exothermic reactions can occur when we do things that are not beneficial in the long term. For example, when we invest energy into enforcing laws that restrict others, in the short term we see benefits. Jailing someone who was a nuisance to society is beneficial in the short term. However, in the long term, when we jail or punish more and more people and expand the reasons for doing it, society is on the road to collapse. Initially, it will have short-term gains that will make the society more energetic. But in the long term, if it does not relent, then the exothermic reaction will proceed and society at large will fall to a lower steady state. In other words, in an exothermic reaction, as energy is invested, the total energy of the system increases until it doesn't. In a way, these two forms of reactions act similarly to a stairway. If we walk upstairs, it is more difficult than going downstairs. But if we make it up the stairs, then we can move around freely on the next level just as easily as we can on the previous level. We just have to first make it up the steps. As a society, when we make short-term decisions, we do so at the expense of the long term. When we make decisions for the long term, we do so at the expense of the short term. This is the same as taking stairs upward. It is hard up front, but then we can get to where we are going where it is easy. Or we can take the stairs downward, where it is easiest up front. But then we need to retrace our steps and take the stairs anyway if we want to go higher and have more potential energy. This increase in potential energy gives more freedom, more happiness, more contentment, more equality, more everything, all of which come at the expense of having to walk up the stairs to get there. It is not an easy road, but it is a worthwhile one. Fortunately for us, when we have people up the stairs, they can build things like harnesses to throw down and pull people up so the road becomes easier. In fact, the process is very much like a road. First, it is an untraveled path. Over time, a trail is cut through because a few individuals go that way. Then it is expanded outward to allow for more and more people and cargo to pass. Soon it is paved, having road signs and maps and directories of all sorts to help people get where they are going. Our journey functions in the same manner. All right, thanks for listening. I'll be back in the next one with the meaning of life. Thanks.